Hello and welcome to this video on forces, specifically Newton's third law. Newton's third law is quite possibly the easiest law to state, but one of the hardest ones to understand. Simply, it says for every action there is an equal but opposite reaction. What do I mean by this? What does it mean? Well, in this diagram, this chart that we used at the beginning to kind of understand forces, we used double arrows because while the man is pulling on the rope this way, the rope is pulling on the man this way. There's always a force pulling both ways. We refer to these as force pairs. The force of the man on the rope is equal to the amount of force of the rope on the man. Now, this is the amount of force, not the acceleration, not the mass, but the amount of force. So if something is more massive, say the man in this case, the amount of acceleration he'll experience is less than the amount of acceleration the rope will experience because the rope has a lower mass. And remember, F equals ma. So as mass goes up, acceleration will go down, or as mass goes down, acceleration will go up. So whenever you have a force, there's the same amount of force acting in the opposite direction. We can talk about the man on the ground. The ground is going to exert a normal force on the man, keeping him from falling through the earth, but the man standing on the earth also is going to push down on it. Another way we could state this is that the amount of force exerted in one direction is the same amount as the force exerted in the opposite direction. So, for instance, if the man is pulling on this rope with 30 newtons of force, the rope is pulling back on him with 30 newtons of force. And this is true for every force, every interaction. We refer to these again as force pairs. So the pair of forces. Every force has a pair, every force has its opposite, and it will always act in the opposite direction that the force is acting. The most prolific example of this is the Earth, acting via force gravity. When you hold something up and let it go, the Earth is going to pull it down. It's going to drop. Now, as the Earth is pulling on whatever object you're dropping, the object's also pulling on the Earth. Now, the amount of force will still be the same, but the acceleration experienced will not be, because the Earth is far larger than whatever object you're dropping it on. There's 20 newtons of force that the Earth is pulling on the object. The Earth's going to pull back with 20 newtons, but the Earth has a mass 5.97 times 10 to the 24th kilograms, orders of magnitude larger, which is why you don't see this acceleration. So, Newton's third law, equal but opposite forces. It's a fairly straightforward idea. It's a fairly concrete, simple thing, but it does take a little bit of getting used to. The way I would recommend going about this and thinking about this is going back to these diagrams. The force pairs are just where your arrows are. The force of the man on the air, the force of the air on the man. This arrow here tells you what your force pair is. Let's quickly check your understanding. What is the Newton's third law pair for each of the following forces? The force of the ground pushing up on the baseball player, the force of the bat pushing the ball to the left, the force of the baseball manager in yellow over there pushing down on the fence. Go ahead and give it a try, check back after the pause. Okay, let's go through each of these. The Newton's third law pair for the force of the ground pushing up on the baseball player is the baseball player pushing down on the ground. It's the same two objects, the direction is reversed. The force of the bat pushing the ball to the left is the force of the ball pushing the bat to the right. Again, same two objects, flipped order, opposite direction. The force of the manager in yellow, this gentleman in the back here, pushing down on the fence. Well, the fence has to be pushing up on him. Again, same two objects, opposite direction. Okay, thanks for watching. Have a good day.